Thank you for joining me. Today what we're going to do is we're going to find the integral from 0 to infinity of e to the negative x dx. What I want to point out here is that because infinity is not a number, notice that infinity is not in my domain of e to the negative x. So what I have here is I can't just use the fundamental theorem because this isn't on a defined interval, so I can't just find the antiderivative and be done with this. So instead what I have to do is I have to rewrite this, and I'm going to say, well, what we're going to say is that if we want to find the integral from 0 to infinity, what that really means is that I'm going to find the integral from 0 to some number, we'll say b, of e to the negative x dx. And then we're going to take the limit as b goes towards infinity. So what we have here is an improper integral because I don't have a number as a limit of integration and my function's not defined at not a number. Therefore, what I do instead is, well, if I integrate from 0 to b for any real number b, I can find this integral. And then if I want this, what I really want is to find the limit as b goes towards infinity. Therefore, what I'm going to do is, well, now that I've rewritten it, and b is just a number, e to the negative x is defined on that interval, so I can find the antiderivative. Now, if we go through our techniques here, I think that we can guess that one. So it's going to be e to the negative x, but if I take the derivative of that, I get negative e to the negative x. So I'm off by a factor of -1, so I'm going to multiply by -1. So my antiderivative is going to be negative e to the negative x. I just need 1 because it's a definite integral. So now I'm going to evaluate from 0 to b. So therefore, in order to finish this problem, I'm just going to take the limit as b goes towards infinity of negative e to the negative b minus, and then I'm going to plug in 0, so negative e to the negative 0. So what I end up with is the limit as b goes towards infinity of negative e to the negative b plus e to the 0. And so as I continue to simplify, I get the limit as b goes towards infinity of negative e to the negative b plus 1. Now, in order to finish this up, what I need to do is I need to look at the limit as b goes towards infinity of negative e to the negative b. So I'm actually going to do that off to the side over here. I'm going to get the limit as b goes towards infinity of negative e to the negative b is really the same thing as b goes towards infinity of -1 e to the b. So now if I have -1 over e to the b, what I end up with is as b gets large, I get the number -1 over a huge number. So as b gets large, this term gets smaller and smaller. That is, it's going to go to 0. So therefore, this limit is 0. So now if I go back to my initial problem, we notice that this portion is going to 0. This portion is constant, so it stays 1 the whole time. So the limit as b goes towards infinity is going to be 0 plus 1 or 1. That is that if we take the area under the curve e to the negative x from 0 off towards infinity, that total area over that entire interval is going to be 1. Or more precisely, what's happening is that as we let this interval get larger and larger, that is, we're integrating from 0 to a large number, that area is in total going to get closer and closer to eventually reaching the point 1. Thank you for watching. There are more resources available in the description below if you'd like to follow the links. You can also check out more videos available in the playlist. Please subscribe, and if you know anybody else who would benefit from watching these and get some help in calculus, make sure to share the video with them.